Hey guys, welcome to video 2.4. Today we're going to be talking about isotopes. You can bet that you're going to see isotopes on your Regents exam. So not only do you need to know what they are, make sure you're familiar with the definition because they're going to pop up in questions all throughout the year. So what is an isotope? It's where you have atoms of the same element with different mass numbers. Okay, so they have the same atomic number, but different mass numbers. Okay, so what that means for us, kind of on a practical term, if you're thinking about that, well, if the atomic number is the same, that means they have the same number of what particle? Protons. But if their mass number is different, what's the other particle that makes up mass? That's your neutron. So they have a different number of neutrons. So ions have different numbers of electrons. Isotopes now have different numbers of neutrons. All right, so here's an example. We have carbon has 3 common isotopes. We should be able to calculate the protons, right? Pretty easy, 6. How do I figure out the number of neutrons? Well, I'm going to take my mass number minus my number of protons, and that's going to give me 6 neutrons. And then electrons, do you see a charge anywhere? No charge means it's neutral, so it's going to be the same as our protons. So 6 protons, 6 neutrons, 6 electrons for carbon-12. Let's do the same thing over here. How many protons does carbon-13 have? 6 is still the same. I don't see a charge, so that means electrons are the same. So now to figure out the number of neutrons, I'm taking the mass minus the number of protons. So now I have 7 neutrons there. And likewise over here with carbon-14, we've got 6 protons, 6 electrons because no charge is there. And then again, 14 minus 6 gives me 8. So these are still all atoms of carbon because, again, the atom is identified by the number of protons, but the neutrons, the mass has changed. And these are naturally occurring in nature, okay? A lot of elements, most all elements, guys, have multiple isotopes. And it has to do with like nuclear charge and trying to hold the nucleus together and stuff. It goes deeper than what we need to for this level, so don't worry about the why. Just know that they're there, okay? And they have a different number of neutrons. My encouragement to you right now would be to try pausing the video and figuring out the protons, neutrons, and electrons of uranium-238 and uranium-240. So, let's see what we get. Oh, this is written a little bit differently, right? Maybe it helps for you to write it with this, but note that this is just your hyphen notation. We mentioned it in a previous video. Okay, that hyphenated number, guys, is just your mass number. So if you look on your periodic table, 92 is your atomic number. So that helps out a lot. All right, protons are 92. Do you see a charge anywhere? No. When you have hyphen notation, guys, they're not going to give you a charge. So it's a neutral atom when it's written in hyphen notation. So that means your electrons are going to be 92. So to figure out the number of neutrons, I take my mass number minus my protons, and I'm left with just the neutrons. So 146 is what you should have had here. Same idea over here with uranium-240. Protons stay the same. There's no charge, so my electrons stay the same. And then I'm going to calculate my, my neutrons. So take 240 minus 92, and I get 148. All right, so that's it. Quick, short video. You guys go ahead and do the sample questions and then work on practice number 5, where it's a mixture of counting all the different particles, and you'll have a quiz on it. So I'll see you in the next video.